Imagine a microscopic droplet capable of rewriting the fundamental laws of physics and erasing our massive planet in seconds before you even have the chance to look up at the sky. We aren't talking about an asteroid impact, a global pandemic, or even a supermassive black hole waiting to swallow our solar system. We are talking about a perfect predator lurking in the darkest corners of theoretical physics. A strangelet, a droplet of strange matter. If some of the most extreme models in theoretical physics are correct, this subatomic contagion has the potential to convert everything it touches into a dense, uniform, cosmic sludge. A silent, unstoppable, and completely irreversible extinction. So, do these silent predators, hypothesized to be drifting in the dark oceans of deep space, actually exist? And if they do, could they be heading toward Earth right now? Space travelers, buckle up. Today we are traveling to that eerie boundary where philosophy meets physics. We are investigating the most dangerous, most mysterious substance in the cosmos, and why it, rather than us, might be the true, ultimate form of existence. The architecture of the perfect killer. To understand our enemy, we must first look in the mirror. Understanding the architecture of the universe is actually like understanding a very simple set of Legos. You, me, the screen you're watching this on, the Earth, and the billions of stars shining in the sky, everything we see is made of atoms. And atoms are built from the protons and neutrons at their core. If we could take a magnifying glass to the inside of those protons and neutrons, we would find nature's most fundamental, indivisible building blocks: quarks. According to the Standard Model, all the ordinary matter in the universe is constructed from just two types of quarks: the up quark and the down quark. Just those two. This duo is the foundational alphabet of that giant periodic table we all saw in chemistry class. But the quark family has a strange, overweight, and incredibly unstable member, the strange quark. When we create collisions at massive energies in particle accelerators in our laboratories, these strange quarks sometimes appear. However, they are so heavy that they naturally decay almost instantly, reverting into our familiar, safe up and down quarks. In normal conditions on Earth, they can't survive for even a billionth of a second. But the universe is no ordinary laboratory. Deep in the cosmos, there is a place where these strange quarks not only survive, but achieve perfect equilibrium: the heart of a neutron star. When a massive star exhausts its fuel and dies, it collapses in on itself. It collapses so violently that it crushes a mass twice that of our Sun into an area the size of a small city. This is a neutron star, one of the densest objects in the universe. The gravity and pressure at its core are so mind-boggling that the vast, empty spaces inside atoms are completely crushed. Protons and neutrons are torn apart, and the inside of the star literally turns into a giant quark soup. In this hellish furnace, under unimaginable pressure, the rules change. In this extreme confinement, up and down quarks expend some of their energy and transform into strange quarks. Now, a soup consisting of up, down, and strange quarks has formed, the densest, most ruthless, and most perfect soup in the universe. Physicists call this strange matter. The strange matter hypothesis, an infection mechanism. This is exactly where the philosophical and terrifying aspect begins. What truly terrifies physicists isn't just the existence of this strange matter inside neutron stars, but what it potentially means. Meet one of the most unsettling ideas in theoretical physics: the strange matter hypothesis. According to this hypothesis, strange matter is the true ground state of matter in the universe. What does that mean? Everything in the universe wants to be in its lowest energy state, meaning its most stable form. Just like a rock dropped from the top of a mountain will eventually roll down and come to rest at the very bottom of the valley. We, the Earth, the water, the oxygen, we are ordinary matter stuck in a small ditch on the side of that mountain, vibrating at a high energy state. We think we are perfectly stable. But the strange matter hypothesis dictates that the absolute bottom of the valley, the most stable, perfect form matter can achieve, is actually strange matter. And matter always wants to reach that absolute bottom. So, if strange matter is so perfect, why isn't everything made of it? Because to fall from the side of the mountain to the very bottom, matter needs an incredible driving force, an extreme amount of pressure. Ordinary matter doesn't know the way to convert into strange matter, unless something teaches it. A microscopic droplet breaking away from this strange matter inside a neutron star is called a strangelet. This is a subatomic virus. What happens if a strangelet touches ordinary matter, say the hull of your spaceship, an atom in the atmosphere, or your skin? It whispers to the atoms of ordinary matter, "I can give you the secret to perfect stability, the way to the bottom of the valley." Without even needing that extreme pressure, ordinary matter is drawn into the strangelet, its atomic structure is dismantled, and it instantly transforms into strange matter. It too becomes strange. And this process triggers an unstoppable chain reaction. The newly formed strange matter grows larger and attacks the other atoms around it. This is not a chemical burn or a nuclear explosion. This is the fundamental reprogramming of the concept of matter, of reality itself, like a cosmic zombie virus. The cosmic survival test. All right, if you followed the story this far, let's take a 20-second extinction break. Before we bring the apocalypse down to Earth, let's run an extreme thought experiment. Pause the video right at this second and write your answer in the comments. Let's assume this most aggressive scenario in theoretical physics actually happens. A strangely dense strangelet, just the size of a grain of sand, arriving from the dark depths of space, silently pierces Earth's atmosphere and drops right into the middle of the Pacific Ocean. How long do you think it would take for this subatomic contagion to convert the water, swallow the entire ocean, and then overtake the whole planet? A. About 3 days, maybe giving us time to evacuate the continents. B. Maybe a few hours. We would see massive tsunamis. C. You wouldn't even have time to look up at the sky. If you said A or B, you're way too used to Hollywood movies. You're wrong. The answer is C. Because the theoretical conversion process in this disaster scenario isn't like a chemical spread, it's a subatomic reaction, meaning it travels at nearly the speed of light. If a strangelet touched the ocean, the water wouldn't boil, evaporate, or even ripple. That massive body of water would collapse into that dense, dark, metallic strange matter form in mere fractions of a second. The final transition of Earth. Let's take this thought experiment all the way to the end. What exactly would happen during this final transition? Think about classic cosmic disasters. Asteroid impacts set the Earth on fire. Supernovas scorch the atmosphere. Earthquakes tear continents apart. They all release massive amounts of energy and noise. But a strangelet disaster, by its very nature, is terrifyingly silent. Because no energy is released. On the contrary, everything transitions into a lower energy state. Immediately after swallowing the ocean, the strangelet begins to plunge rapidly toward the Earth's core due to its immense mass and gravity. It gravitationally pulls everything in its path down to the bottom of that perfect valley. The seas, the Himalayan mountains, the billions of tons of oxygen in the atmosphere, our cities, all the civilization we've built, and our bodies. This boundary, called the conversion zone, moves at the speed of light, increasing the density of matter trillions of times over. The empty space that makes up 99.9% of our planet, the void between atomic nuclei and electrons, simply vanishes in an instant. In just a few seconds, or at most a few minutes, our magnificent blue planet, 12,742 kilometers in diameter, collapses in on itself. And do you know what is left behind? A perfectly smooth, hyper-dense, flawless, and dead sphere of strange matter, roughly the size of a football field or a small city block, silently continuing its orbit around the sun. No sound, no explosion, no resistance, just universal uniformity. If surviving these dark, mind-bending thought experiments is exactly your kind of journey, make sure to hit that subscribe button right now and like this video. Join our growing crew of space travelers. We need more brave explorers for what comes next. The reality check. Now, everyone take a deep breath. Let's get our heart rates back to normal. Everything we've discussed up to this point has been a dark horror movie shown to us by physics at the absolute fringes of equations, a mathematical dystopia. But what do the scientific facts and today's empirical evidence actually say? You can relax. For now, there's no need to panic about a strangelet waiting under your bed or in the dark of space. Why? Because strangelets are completely hypothetical particles whose existence has yet to be directly verified. Even though we frantically search for them in the universe and scan signals coming from neutron stars, we still haven't found any definitive proof to say, this is a droplet of strange matter. Furthermore, that bold hypothesis we just discussed, that short-lived strange quarks in the lab suggests strange matter is the absolute and stable ground state of the universe, is not a universally accepted law in the physics community. It is still a highly debated, speculative prediction. Yes, in the early 2000s, when atoms started being smashed together at massive energies at CERN in Switzerland, the fear of, what if we accidentally create a microscopic strangelet and it swallows the Earth, caused a massive media uproar. Some people even filed lawsuits to stop the experiments. But physicists responded with a much clearer piece of evidence. The universe has already been bombarding our atmosphere for billions of years with cosmic rays, packing energies millions of times more powerful than what the machines at CERN could ever produce. Massive atomic collisions are happening up there every single second. If these collisions could easily create strangelets and destroy the world, we would have already been shrunk down to the size of a football field eons ago. The fact that our planet is still here is the greatest proof that this risk is practically zero. The Fermi paradox and the exit. So, yes, strange matter might be the universe's most perfect killer. But for now, they are trapped on our chalkboards, in our sci-fi fantasies, and within our mathematical equations. Still, when we look out into the freezing silence of the universe, one can't help but wonder. You know, the famous Fermi paradox constantly asks us, if the universe is filled with billions of galaxies and countless habitable planets, why is space so quiet? Why haven't we encountered any advanced civilizations? Perhaps the great filter that wipes out civilizations in the universe isn't nuclear war or asteroids. Perhaps it's those invisible, microscopic, strangelet ghost ships, expelled into the dark ocean of space by colliding neutron stars, drifting aimlessly for trillions of years. The universe might be erasing those who get too close to the boundaries of mathematics with this silent, perfect uniformity. We are just the lucky passengers who haven't been caught in that storm yet. The fate of the universe might indeed be to drift toward this cold, uniform darkness. However, the only real gravity monsters waiting in the dark aren't hypothetical. We know for a fact that there are beasts out there swallowing stars whole and bending time itself. If you haven't yet seen our journeys beyond the microscopic terror of strangelets and into those massive dark voids where the limits of physics break down, into black holes and the mind-bending weirdness of the quantum world, click the video on the screen right now and continue exploring the edges of our known universe with us. And before you jump into the nearest black hole, don't forget to subscribe to the channel and leave a like to fuel our spaceship for the next adventure. Stay in space, stay safe. See you on the next journey of the space traveler.